we signed an agreement with Christopher Burke some time ago about doing a levee survey and freeboard analysis, and I've shared with you some of the information that over the course of time, parts and pieces. But this is going to be sort of like a full overview of what he sees, what it's compared to for the 200-year flood event to the as-built, and maybe a couple places where we need to address, going forward that maybe the Corps may have missed. So with that, AJ, I hope I didn't steal your entire report, so go with it. You want
Right. Thank you, Mr. Repay. Just to check the audio, can you hear me okay?
Yeah.
Okay, excellent. I will share my screen now to get the presentation going. You can give me a confirmation that you can see my screen okay?
We got you.
All right, excellent. Thank you for the opportunity to present tonight on the surveying and freeboard analysis that we're conducting for you on the Little Calumet River levee system.
Oh.
Okay, get the slide to advance here. There we go. Give you a brief outline of my presentation. First, I would like to discuss the purpose and scope of the project that we're doing for you. And then I will talk about the survey data collection and the information that we gathered from that. Following that, I will get into the freeboard analysis and our findings, and then talk about the next steps where we go from here. So first, let's start with the project purpose and scope. The purpose of our project was to evaluate the levee system freeboard, or the height of the levee, with respect to FEMA requirements. So we also wanted to collect data that could be leveraged in the future to apply for a letter of map revision, or LOMAR, or continuation of the previous LOMARs with FEMA. So as a reminder, a LOMAR, or a letter of map revision, is a process where FEMA revises the flood insurance rate maps to reflect the benefits of the levee. It was mentioned earlier in the meeting that previous LOMAR efforts that the Basin Commission has initiated has resulted in great benefits for the community west of Klein Avenue. Those communities are no longer subject to the mandatory flood insurance purchase requirements and development restrictions that those communities must enforce as a participant in the National Flood Insurance Program. The East Reach levees that are east of Klein Avenue have not received a letter of map revision despite some of the past efforts, but there are ongoing efforts to try to achieve that. The scope of our work included collecting and processing survey data for 30 plus miles of levee, and I'll show you a map on the next slide exactly where we were working within the system. And then we performed a freeboard evaluation, which was a comparison of the actual levee height to the required height. And we've got some graphics to share tonight as well. So this map shows the Little Calumet River levee system in its entirety. As you well know, it extends from the state line, Indiana-Illinois state line, to the east to the interchange of I-80/94 and Interstate 65. All the levees are shown in various colors here, representing the different segments. Our evaluation included all segments, and I'll hover over them as I talk. We have the Hammond Forest Avenue segment. We have the Hammond levee. We have the Munster levee, the Highland levee, the Gary North levee, the Burr Street levee, the Gary South levee. We also have the Marshalltown levee, and then a couple segments which the Army Corps refers to as non-project segments. These are segments that were constructed by others, or they existed prior to the federal project, and those notably are the INDOT non-project segment at the interchange, as well as the railroad non-project segment, which is an extension of the Gary North levee that goes along the railroad here to the north. Our survey data collection was performed using an unmanned aerial vehicle, or a drone, that used a LiDAR scanner that was mounted to that drone. and it collected a dense cloud of points, a bunch of data, which we then screened through, and it's extracted elevations from those at approximately 100-foot intervals, as well as areas that were of importance to us at road crossings, at transitions from levee to flood wall, and in other important areas. The accuracy of our data was really, really good. With the drone, we can get accuracy up to about 1 inch, which is commensurate with and in line with ground survey accuracies as well. So we're able to collect very good data using the drone. And we were also able to collect very high resolution aerial photography along the flight. So I provided a sample of what that aerial photography looks like. And I really like this one. I shared this with Mr. Repay earlier. It is so clear that you can see people on the mowers while they're out here. And if I could zoom in a little further, you could even almost see who it is on the mower. It's very good imagery. That is great data that's collected that we can share with the Basin Commission. One of the challenges that we encountered was how to present such a large amount of information in a meaningful way. We could easily see this information on our computer screens back at the office, but we wanted to know how best we can share this with the Basin Commission and with others. So we ultimately decided to share this information in 2 ways. The first way was to produce a static map, like you see on the screen here, that showed elevation points along the levees, again at approximately 100-foot intervals. So as you go along all these levee segments, this particular area is just west of Indianapolis Boulevard. We're seeing the Highland Levee, the Munster Levee, and the Hammond Levee, and we have all these elevation points, again, at approximately 100-foot intervals. So we have static maps that we've shared with the Basin Commission already. In total, there are 15 of these maps for the 30-plus miles of levee that we study. And these maps are good. They're fine and dandy, but we wanted to give you an even better way of seeing this. So we created an online portal or platform so that the Basin Commission or others as needed could view this information digitally and interactively. So the screenshot you see here is very similar to that static map that you saw earlier, but this is from our online platform. And I'm going to attempt here to show you our online platform. If I can escape here and go to that. So this is the online platform, and you can zoom in to any location within the levee system. And I've just chosen Klein Avenue as a starting point, but you can peruse and go anywhere in this levee system, scan, pan, and you can see what the elevation of the crest of the levee is at anywhere within the levee system, all throughout the 30-plus miles from the Indiana-Illinois state line all the way to the interchange. So I'll just peruse a couple other areas here just so you can see the amount of data that's available here. Obviously, you have to zoom in to start seeing these points, but this is a very user-friendly platform that anyone with a computer and connection to internet can use. So we hope that this platform is very valuable to you, not only for this assignment, but also for the future, just having all this data available readily to you.
Oh, is that cool?
Okay. So I'm going to get to the next slide here back in the presentation. Talking about Freeboard, I've used this term several times already, but wanted to make sure that we all were on the same page as to what that means. Freeboard is the vertical distance between the top of the levee and the water level that can be expected during the base flood. So I like to use this graphic down here at the bottom. I'm going to try to get this laser pointer back. So this is just a rough schematic of a levee, an earthen embankment, like a lot of areas within this system. And then we know what the flood elevation is. And then the levee is elevated, that crest is a certain distance higher than the flood elevation. And that difference between the levee crest and the flood elevation is called freeboard. And it provides a factor of safety and accounts for many of the unknowns that can contribute to higher flood elevations than we expect, such as debris getting caught on a bridge or some other factor that makes things worse than we expect. So we build in freeboard to levees in our designs to account for some of that uncertainty. So when we look at the criteria that FEMA looks at for accrediting levees or recognizing them on the flood insurance rate maps, we have to look at the Code of Federal Regulations, specifically what's called 44 CFR 6510. That's the section of the Code of Federal Regulations that deals with floodplain mapping. And we find when we look at that, that the freeboard is based on the 1% annual chance flood, or the 100-year flood event. This is a flood that has a 1% chance of occurring in any given year. So that's the baseline flood that we're looking at for FEMA purposes. The Code of Federal Regulations goes on to say that the levees, to meet their criteria, must be 3 feet. There must be 3 feet of freeboard above that 100-year elevation across the entirety of the system. And then there has to be an additional half a foot above that minimum at the upstream end of the levee. So that would make it 3.5 feet. And then that would taper to no less than 3 feet at the downstream end. So that kind of gets a little bit complicated, this taper, especially when you're working with 30 plus miles of levee and also a system that's complex. We've got a control structure at Heart Ditch. We've got flow splitting in different directions. So what we decided for this assignment was that we were going to use 3.5 feet everywhere instead of applying that taper. And that was a conservative assumption. It accounts for some uncertainties in how FEMA would view this. And also it provides us a little bit of a buffer in the event that flood elevations go up slightly in the future. So basically 3.5 feet everywhere above the base flood elevation is what we're looking at for the height of the levee. I want to add one more thing to that, and this does occur in several locations throughout the system, is that there has to be an additional 1 foot of levee height upstream and downstream of bridge crossings. And the reason behind that is because debris can get clogged up in those bridge crossings and create a little bit of a surcharge in those areas. So you'll see some spikes in some lines here when I show you some graphics, and that's what that additional 1 foot represents. I also wanted to point out that this assignment, we're looking at FEMA requirements because that's what drives the flood insurance rate maps. But I wanted to make it very clear that this levee system was designed specifically for Army Corps of Engineers requirements. And the design criteria that they used was the 0.5% annual chance flood, or the 200-year flood, plus a variable amount of additional freeboard. Generally throughout the system there, except the Marshalltown levee, that's a little bit of an exception. But I did want to point out that there were different criteria from the original design and the FEMA criteria that we look at right now for the levee accreditation. This graph is an example of one of the profiles that we created. I'm going to walk you through this. There's a lot of information here. And if I could figure out how to move this ribbon up here at the top, I would, but there we go. How about that? I'll walk you through what all this means. This particular graphic is specifically for the Gary South levee, but we created one of these graphics for each of the levee segments that we talked about earlier. So we're going to start at the bottom here with the dashed blue line. The dashed blue line is the 100-year flood elevation from the current effective FEMA flood insurance study. So this is the regulatory flood elevation along Little Calumet River. And I'll point out while we're down here at the bottom of the graphic, we've got all the roads labeled too, so you can find out where you are within the system. This particular graphic on the far left is Chase Street, and on the far right is MLK. The next line we're going to look at here is the solid blue line. The solid blue line is the freeboard line. So we talked about that last slide of 3.5 feet above the base flood elevation. So what you're seeing here is a 3.5 foot offset of that line. And we're also seeing those little bitty jumps here at road crossings. That's that extra foot of freeboard that's required upstream and downstream of crossings, 100 feet. And this is the line that the levee needs to be at or above this line to meet the FEMA requirements. The red line is the surveyed levee crest line that we got from the drone. So this is our elevation data that we had showed you. We plotted that against the blue line. And what we're really looking at here is the red line above the blue line. That means that the FEMA requirements are met. And clearly here, the red line is above the blue line in all areas, except for where we have temporary closures at road crossings. So the actual elevation when you install the sandbags or whatever type of closure you have is going to be up higher than the blue line. So we are good everywhere on the Gary South levee. One other line I wanted to point out was the green line. We also plotted the Army Corps of Engineers as-built elevations as best as we could from paper drawings. We plotted those on here because we wanted to see how that compared with the red surveyed line. And as you can see, there's pretty good agreement here. There's no huge deviations. Obviously, there are some differences, but the red lines and the green lines generally coincide, which gave us a level of comfort that our survey data was checking out as well. So overall, our findings here, I know I just talked about the Gary South levee, but overall for the 30+ miles of levee, in general, there's adequate freeboard or levee height for the FEMA criteria throughout the entirety of the levee system. But we did find a couple very small areas throughout the system where that red line was slightly below that solid blue line. But those differences were extremely small and they were for very short lengths. And a lot of times they would occur in those areas where you had to have the extra foot of freeboard. But wanted to point out that, and we'll get into this on the next slide, before coming up with recommendations on maybe a structural modification to the levee, we want to do some additional analysis hydraulically and maybe make some less conservative assumptions about that taper to see if we can meet all the requirements that way first. But more on that in a minute. As I also mentioned on that graphic, there were no major deviations between the surveyed levee crest line and the Army Corps as-built. So that red line and that green line were matching up pretty well. What we also identified as part of this project, at least for the East Reach levees that are east of Klein Avenue, primarily in Gary, when FEMA is approached in the future for a letter of map revision request, we definitely want to affirm with them the acceptability of the terminal points of those levees where they end and tie into natural high ground. Those are very important areas that FEMA looks at in those submittals. I wanted to highlight the western terminus of the Burr Street levee and the northern western terminus of the Gary North levee north of I-80/94. Those are two areas that we'd want to look into in close detail as part of a future LOMAR request, just to make sure that those meet all the requirements. Next steps and conclusions here. This is my last slide, and I'll be glad to open it up to any questions. But we are currently authorized by the commission to perform a two-dimensional hydraulic analysis of Little Calumet River. This will serve as an update to the existing flood elevations. This model is expected to be more accurate than the current flood elevations. So what we want to do when we're done with that work is to update those freeboard profiles for each levee segment using those new flood elevations. And based on that information, we'll then provide specific recommendations for any improvements that need to be made to address any freeboard deficiencies for the FEMA requirements. So We're hopeful that the new flood elevations will be at or below the current flood elevations. We're keeping our fingers crossed for that. That would certainly be a good sign. But we'll cross those bridges when they come, and we'll update those profiles when we get there. But overall, good news that the levee system meets the height requirements for FEMA for the vast majority of the system. So I'm at the end of the presentation now, and would be glad to answer any questions that you might have.
Gentlemen, any questions for this young man? That was a fabulous overview. Thank you very much.
Concur, Mr. Chairman, I do have some
Thank you,
questions.
Chairman.
Yes. Mr. Broadnex.
Thank you. AJ, right?
Yes. Yes, sir.
Okay, good. Yeah, I have like 4 or 5 questions. Couple
Yeah,
first
be glad to answer.
first 3 are sort of administrative.
Yeah.
One of the first slides you said something about you implied a difference between a LOMAR and a continuation of an existing LOMAR. What's the significance of that?
Yeah, that's a really good question, and one that really doesn't have a clear answer out there, but I'll try to answer as best as I can. So for projects that have an existing letter of map revision, like the levees that are west of Klein Avenue, we are not familiar with a process whereby FEMA goes back and reevaluates those at a certain time interval to check that they're still meeting all the requirements. In our experience, once you have a letter of map revision, that is in effect indefinitely. So
until you fail or something, right?
Yeah, until there's something that would prompt a change.
Okay.
There may be a change in how FEMA views that in the future, but in our experience, there's been no going back and rechecking or reevaluating a letter of map revision unless there's something that prompts that.
Okay, thank you.
Yeah.
The second one, terminology, you used the term dense cloud, and I guess that ties to the every 100 feet or so. Is there another sort of, I don't know, less dense, sparse cloud that you could use? And what's the difference in accuracy that we would get or something like that?
Yeah. So let me go back to that slide. I'm not sure the slide will help answer your question or not, but
yeah,
when that drone flies along the levee, it's continuously collecting elevation data as it flies. So it's shooting down information's going back up. So it's collecting a very dense
that might answer my fourth question.
Point cloud, if you want to call it that. And then we get a lot of information that we have to sift through a little bit to make sure that we're extracting the useful information from that, because not all that data we really want, but we're collecting it as we're going along.
Okay. Actually, it was going to be my fourth question, but it's related to this then, I think maybe. You use the term crest of the levee, and I'm thinking it's a wall. Why would you have a crest or a slope? But I did notice that the red line compared to the green line, the red line looked like a mountain range and the green line looked like a wall. Is that indicative of the fact that, and tying to all of these points of data that you're getting, that it's getting like every little variance in elevation as we go? So like little dips and things, is that what that's reflective of?
Yeah, that's a really good question, and I'd like to clarify that we also, not only the earthen levees included in this, but also the flood walls. So that was one of the areas where we really had to sift through the data, because the levee crest on an earthen levee is much wider than the narrow top of the flood wall. But we indeed were able to get the top of flood wall elevations as we went along, and you do see those ups and downs. There are subtle differences. They look huge on this graph, but I think it's a little bit distorted by scale, because each of these tick marks down here is 200 feet, I believe. Let me make sure that, Anthony, 200 feet down here on the bottom. And then we've got, a foot in this area. Okay, so it's kind of distorted a little bit. So that's why you're seeing all these.
Over 200. Okay.
Yeah. So.
Okay. I was wondering, it's like, man, is our wall good?
Yeah,
Okay,
when you go out there
and I
and look
also
at it,
forgot
you're
that
not going to
certain
see
levee
that with your
Yeah.
eye.
Okay, very good.
Really good
And then
question.
okay, thanks. And the last one was you mentioned a couple times about transmitting the information to us or others.
Yeah.
And I forget sometimes we're public, but when I hear that in my private work, I'm thinking, wait a minute, this is our data. Who else would
Yeah.
you be communicating this information to? Or is that just a general acknowledgement that we may want to share it? Or is there like a plan to share this information with somebody else?
Yeah, it's just a general acknowledgement that if you want to share it with others, that you have the ability to do that with the link that we provided you. It's not
Right.
a private
Okay.
connection. We haven't sent it to anyone else other than you, but you can share that with others if you so desire.
Perfect. I don't have any more questions, Mr. Chairman. Thank you, AJ.
Anyone else?
Okay, you're welcome.
I have a question with regards to the drone flyover and the high resolution pictures. Mr. Repay always wants to see pictures and have them data as far as where the dates were and the time that was shot. And will we have access to those?
Yes, Mr. Chairman, we can provide that digital data. It's a large file size, so we may need to send it to you on a disk. And we're also going to see if we can get that uploaded to the online portal as well.
Thank you. Yeah, because if there's ways to do it, especially of the snapshots, for lack of a better term, because I'm old, where those locations are, because some of the more remote areas, that becomes more and more prevalent as we try to see before and afters.
Yes, sir.
Thank you.
Make that happen.
Chair, just one more
Yes, sir.
question. You can go, guy.
No, go ahead.
I thought he had a question.
Oh. Go ahead.
Great presentation, by the way.
Mine is simple. Maybe you know the answer to this, maybe you don't. But when you guys start your borings, what do you plan on doing with the material that you bore and drill?
Yes, so a geotechnical investigation is planned for the levee. We're still trying to work out the details with the U.S. Army Corps with the Section 408 permit, as Mr. Repay alluded to earlier. So the exact plans for the disposal of those materials is still to be determined. But we probably need to find a location near the levee to dispose of those cuttings.
And you're just waiting for clearance from the Army Corps on?
Yes, we need permit approval to commence the work.
Okay, thank you.
It's you guys, Deck.
Yeah, Mr. Chair, I have a question. AJ, for the green lines and the anomalies at 35th,
Yeah.
and what do you guys attribute that to?
Yeah, so great question. 35th Avenue is an interesting one here. That's one of the locations where the Basin Commission came in after the federal project and raised the road profile in that area. So that's why there's such a huge anomaly there, from the green line to the red line, because there was a project that was initiated after the green line plans. That's why we're not seeing as much of a correlation there.
Thank you.
You're welcome.
Tom, is that where or Dan, is that where the Corps was basically planning for 35th to flood as part of the project?
So no, 35th, remember, had the panels that were stored in the fruit shop, the old fruit shop.
Yeah.
And then we built the over, and then the same for Harrison, where we rebuilt the bridge, where it had been, we had, those are all closure structures where we had to put the 33,000 sandbags. So when we raised Georgia and Harrison at 35th with the panels, that's why the as-built show as so low. And then now the red with where they flew it over shows where it is now, so we don't have to close that area. So the only closures in Gary that we would have is Grant and Broadway. And I don't think that shows up here, does it?
Yeah, here you go, Dan. You can see we're showing those temporary closures right here at Grant, and then Broadway is also over here. But you're exactly right. Georgia and Harrison are very similar to 35th, where you have these big spikes in this green line, but Little Calumet Basin Commission has initiated projects there since the as-builts were created.
Mr. Wishlinski.
Touching on what Commissioner Whitaker was asking, when you do the borings, obviously you're still going through the approvals from the Corps.
Yeah.
Are you gonna inject those holes with the slurry or some sort of cementitious material after you take the boring?
Yes, those borings will be likely backfilled with a bentonite material, bentonite grout or bentonite chips. We're still ironing out the details on that, but that's typically the backfill that is used in these type of applications.
All right, any other questions? Thank you very much. That was very well done. Appreciate it.